Alrighty, welcome to Algebra 1, lesson 88. We're going to learn about multiplying and dividing rational expressions, meaning they have fractions, but they have the variables with them, and you have to simplify as much as you can. When you're simplifying variables, you have to make sure there's one variable in that fraction. You can't have an x in the numerator and denominator. Two rules about basic fraction is when you're multiplying two different fractions, you multiply across. So AC, A times C is AC, B times D is BD. So you multiply across, and that's how you can just get your fraction there. You simplify, of course. And then dividing is where it's a little bit different. When you're dividing fractions, what that means is you're multiplying the second one. You're multiplying by the reciprocal of the second one. So here is AB divided by CD. This is equal to AB times the reciprocal, which is D over C. So you're always multiplying by the reciprocal of the second one. And then you multiply across, because now you're multiplying. Example 1. When you're working with these type of problems, go step by step. What I do is, they are fractions. So that means I follow this rule. I multiply across. When I multiply across, 6 times 7, I get 42. X, and then when I look at this numerator here, when you're multiplying variables, you add the exponents. So for the x's, I have 4 plus 2, I have x to the 6. I have 1 plus 2, I have y cubed. Over, and now I look at my denominator. 21 times 3 is 63. X times x squared, that means you're adding, so it's x cubed. 3 plus 2, you're going to get y to the 5th. Multiplying everything across. For variables, you're just adding the exponents. Here, what I like to do, and this is like the faster way, is separate the numbers and variables. So I have x6, y cubed. So I separate the numbers, and I have 42 over 63. This works if you're not used to subtracting the variables. What I would do for my second one, I'm going to move all of these variables up here, just so I can combine them and then move them up or down when I need to. So that means these two I'm bringing up. So this x cubed now becomes x to the negative cubed. Y to the 5th now becomes y to the negative 5th. I'm bringing everything up because I have a couple x's and a couple y's. So remember, when you bring it up, it's all over 1. Here, 42 over 63, you try to find the common factor there. What I do, it's the easiest thing to do, it's a trick. Just put as a fraction in your calculator. 42 over, not divided, 42 over 63, and you end up with a simplified form of 2 over 3. Very easy, unless you can just find common factor, which there is one. And now here, I have all these variables, I brought them up, now I combine them, meaning they're multiplying, so that means I add them. So the x is 6 minus 3. So 6 plus negative 3 is x to the 3rd power. 3 minus 5, I have y to the negative 2nd power over 1. Here, let's go ahead and multiply everything together, but before I do that, I have a negative. When you're simplifying these type of problems, you can never have a negative exponent. You can't leave it like that. So here, I'm going to bring it down, because remember, when you're crossing that fraction bar line, it changes their sign. Now I have 2 over 3 times x cubed. It was positive, so it stays up there. When I bring this down, I get y squared. And from this point, I just multiply across. 2x cubed over 3y squared, and that's your answer. B. Again, same type of problem, we multiply across. If you want, you can find common terms. Remember, when you're trying to cancel out terms, they always have to be across from each other. They can't be in the same level, so they have to be in opposite levels. Here, multiply across. 6 times 3 is 18. X2 times x gives you x cubed, adding the exponents. 5 times 7, 35. Y fourth times y squared is y to the 6th. Here, you try to see if there's anything you can simplify. If you put 18 over 35 in your calculator, it still stays as 18 over 35. X and y, they are two completely different variables. You cannot combine them, and you want to leave it like that. So in this case, this is as simplified as you can get. And you're always making sure you can simplify as much as you can. Now, let's move on to factors. When you're going to Algebra 2, we deal with these numbers all the time. Take it one step at a time. Anytime I see the squared, I always think of factoring. And when you're always thinking of factoring and have the rules up there, you always factor out the greatest common factor first. Always, always, always. So here, let's look at the first fraction here. So these two are multiplying. This is an expression there, so just like we have 3 times 1/2. That 3, the whole number, you can make into a fraction by putting it over 1. So I just made it as 2 fractions. When you have 2 fractions, you multiply across. Now here, let's go ahead and simplify the first fraction. We have 9. 9 can't be simplified. You're not going to undo 9. 9 just stays at 9. 3x minus 15. The number 1 rule, factor out the greatest common factor if possible. Now here, there is a common factor of 3. When I factor out the 3, I get x minus negative 15 divided by 3, negative 5. So 3 times x minus 5. That's where you want to leave it. Now the second one, it's multiplying. This is over 1. I'm going to factor this up here. So x squared minus 2x minus 15. I'm finding factors of negative 15 that equal negative 2. That would be negative 5 and positive 3. Negative 5 times 3 gives you negative 15, but when you add them together, you also get negative 2. So that means you have x minus 5 and x plus 3. Now we have these two terms and they're multiplying. Before you go ahead and multiply across, I have step 2 as cancel out common factors. See if there's anything that cancel out. Again, if they're in the same level, you cannot factor or you cannot cancel them out. So it looks like there is an x minus 5 up here and an x minus 5 up there or down there, so you can cancel them out. But you're also looking for numbers too or variables. If I look here, I have a 3 and I have a 9, they're multiplying. Here's x plus 3. I cannot separate the 3 out. X and 3, they're married, so they're combined. You cannot separate them at all. But here, 3 is on the outside. So therefore, I can cancel anything with that 3. There's a 9 and a 3 here, and looks like they have a common factor of 3. 3 can go into 3 once. 3 can go into 9, 3. Now, when I multiply across, I get 3 times x plus 3 over, and this is 1. It's just over 1, so I'm just going to leave it as that, because anything over 1 is the same number itself. Here, I have this so far, but I want to simplify even further this derivative property. I have 3x plus 9, and that is your answer for that one. So take it a step at a time. Example 3. So here we don't have any x squared, any binomials, but we can factor out. I always make sure to factor out every section at a time before I start multiplying together. So here we didn't have anything adding or subtracting. That's why example 1 and example 2 and 3 and the rest of them are different. There's signs in between these. Remember, signs, you cannot separate them, but you can factor stuff out of them. So here, 8 and 2, you can factor out a 2. So I'm just focusing on this one. I can factor out a 2. It looks like they each have at least one m and one n. So I factor that out. When I factor that out, 8 divided by 2 is 4. 2 minus 1 is m, and the n's cancel out. Now I can do plus 2mn. If you notice, they're the same numbers. 2mn divided by 2mn, you end up with a 1. And then underneath, over 2m, you can't simplify that, so you end up with 2m. Now, remember you're multiplying. Now you want to factor this out here. 15. You can't really factor out 15, so you leave it like that. 24mn plus 6, there's a plus sign, meaning you can factor stuff out, and then you can factor out greatest common factor. Here, they have a greatest common factor for number-wise is 6. And then you look, they don't have m's, but they have an n. So when you do that, you have 4m plus 1. Now, let's go ahead and cancel anything we see. We have this over here and this over here. They're exactly the same. If they're opposite signs, you cannot cancel them out. Exactly the same numbers, exactly the same signs. Also, if I noticed here, looking number-wise, 2 can go into 2 once, so I'm just left with 1. M can go into m once. Or we can bring this m down, another way you can see it. You have m to the negative 1, so m minus 1. So 1 minus 1 gives you m to the 0. But if you notice that they have the same number of exponents and they're on the top and bottom, they automatically cancel out completely. So here, m minus negative 1, m, they cancel out, and that's why you have no m's. Now, the n here, it looks like you can still cancel them out. It looks like there's an n here. They have the same exponent. So that means you can cancel them out. And now last thing is 15 and 6. They do have a number in common. They have a 3 in common. 3 goes into 6 twice. 3 goes into 15 5 times. So multiply everything across. Everything canceled out except this 5 up here. Everything canceled out here except the 2 over here. And left with 5 over 2. Example 4. So we're going to try to speed this up. Now we're dividing. When you're dividing, make sure you are multiplying by the reciprocal. So I'm going to go ahead and flip this. 5st4 over 4s squared t times, you flip it. So now your denominator is on top, is up here, and then your numerator is on the bottom. Now multiplying. So this looks like rational equation, looks like example 1. There's nothing adding or subtracting, so you just multiply across. 5 times 2 is 10. 1 plus 3, s to the 4. 4 plus 2 is s to the 6, or t to the 6. 4 times 15 is 60. S 2 and 2 is s to the 4, and t is t to the 2nd power. So you just multiply across accordingly. Now, separate the numbers with the variables, and remember, variables, go ahead and bring them all up. T to the 6. This s to the 4 is going to turn into s to the negative 4. The t squared is going to turn into t minus 2, and then go ahead and simplify everything here. So now simplifying one side at a time. 10 over 60, 1/6. Times 4 minus 4, these cancel out. 6 minus 2 gives you t to the 4th power, and then you multiply. This is a t. You multiply across. So remember, if this is a whole number, this is all over 1. Multiply across, you get t to the 4th power over 6, and that's your answer. Now going on to the next one. Here, you're dividing, so go ahead and flip it. You always flip it first before you start simplifying anything. So now we're dealing with the plus or minus signs in between. That means we're going to do some greatest common factoring. So we have this fraction. Now we're going to put it in terms of multiplication. So remember, this is like that expression over 1. So if you're doing the reciprocal, it's going to be 1 over that expression. It's always over 1 if there's no fraction bar. Now, let's go ahead and simplify as much as we can. The top right here, we can simplify this. There's a number in common, which is 3. They have at least one r, so I can go ahead and factor that out. 9 divided by 3, 3. 2 minus 1, r. Negative 12 divided by 3, minus 4, r and r, they cancel out. The denominator here, you can't simplify it. I'm putting it over 27. Next thing, bring the sign over. And now here, we have fraction. The 1 can't be simplified, and this also can't be simplified. But if you noticed, these can cancel out. Now you go and cancel any common factor. So you can cancel those r. The r, there's nothing on the r on the outside. They can cancel out. 3 and 27, you can cancel them out. 3 goes into 3 once. 3 goes into 27 9 times. And when you multiply across, making sure I got this right, so there's an r left over. So you have the r on top over 9, and we have the 9 left over there. All right, just 2 more. All right, now this one here, now they have more of an expression. Let's go ahead and flip them. They are dividing. That's the first step at every time when you're dividing fractions. So this stays the same, and here it says divided, so I'm going to flip it. So multiplying by the reciprocal, which is x over x plus 3. I always put parentheses over binomials, meaning I can't touch them, I can't separate them unless I factor something out. Now, let's go ahead and start simplifying. The first one here. The top one is a trinomial. So I look for common factors. Factors of c, which is plus 3, that equal 4, that would be x plus 3, x plus 1. So 3, that equal 4, positive 3 and positive 1, because this is a positive 4. So I simplified that, or factored it. The denominator, x squared, just stays as x squared. Going across, it looks like you can't simplify anything from that side anymore, so I have this. Now let's go ahead and start canceling things out. This can cancel out with this. X squared, and we have an x here. We have an x in each one. Let's go ahead and just multiply across so we can see what we're working with. We have an x here, we have an x squared here. So this is all that's left in the numerator and denominator. If I were to bring this term down, so I always want to bring the smaller factor down. If there's 2 variables in the top and bottom, I want to bring the smaller one to whichever is closer to the bigger one. So here, if I move the x to the 1 power to the denominator, I have x to the negative 1 power. I end up with, since this moved out, this cancels out, I have x plus 1 numerator. Negative 1 plus 2, or 2 minus 1, just gives me x. You cannot cancel these x's out. Remember, when they're in the parentheses, you can't cancel them out. If you want to cancel them out, you have to cancel out the whole thing, and you can't. So in this case, this will be your simplified answer. Last one is this one. You have a number here. They have the whole storyline in your book. You can look at it later. But the whole thing is looking at this and multiplying it out. So we have a trinomial. Remember, it's always over 1. It's multiplying, so we're not flipping anything. Now we go ahead and simplify each section. So 100x squared plus 100x, you can factor that. You can factor out 100, and you can factor out at least 1x. When you do that, 100, 100, 1, 2 minus 1, x, 100x divided by 100x plus 1. So that's what I get for my denominator. Here, so times, I'm going to put it as a fraction. You factor this. Find factors of 4 that equal 5. And the only factors I can think of is 4 times 1, and that gives you your positive 5. So x plus 4, x plus 1. Now, let's start canceling things out. This can cancel out to this. X, if I bring it up here, it turns into x minus 1. We always want to make sure we combine all the x's together. And we get, multiplying across, minus 1, 4 minus 1, x cubed times x to the 4th power over, here it looks like we just had 100 left over. Because this moved up here, that's why this canceled out. And this will be your completed answer. If you have any more questions, make sure to email them down there. But just take this step at a time. It is very easy if you take it one step at a time. And remember all the rules. Bye-bye.